Hey everyone, thank you all for joining. My name is Nebojsa. I'm one of the co-founders at Tenderly, and I'm also the lead for our R&D team. With me is Marco, one of the R&D engineers, who's going to help me out with the live demo. Hopefully nothing goes wrong. Today we're going to be talking about Ethdebug format for smart contract debugging. So what is Ethdebug format? So a brief history, some year and a half ago, after the merge in Bogota DevConnect, we assembled as a group consisting of Solidity developers, a tooling company focused on building debuggers, and tooling company focused on building security analysis tools. And we started talking about what's missing from the tooling perspective and what can we do to make lives of developer easier. And we sat down with the Solidity team and we started giving them feedback. Fast forward some year and a half ago, we now have this group that meets usually once every week, where we talk about the specification of the format that Solidity compiler and hopefully other EVM compilers are going to implement in order for the tooling to get to the next level. So why having a good debugger is important? Well, for all the similar reasons for why the debugger is important in Web 2, so all the essential stuff that the developer use it for, such as navigating through the code, understanding how the execution is correlated with the source code, what's going on the high level, and if an error occurs, it helps them navigate to the bug much easier. On top of that, in Web 3, the stakes are much higher, and the bugs that could occur in production are usually irreversible. So one aspect of it is, of course, the security. So whenever you're developing smart contracts, in most cases, a lot of funds are going to be stored on them. So you want to make sure that everything is working and that there are no bugs. The second thing is that you're usually interacting with some other third-party contracts. Navigating and managing complexity is one of the most important things in the Web 3. So a good debugger should help with that as well. And of course, it enhances your confidence and reliability in your code once you push it to the production. All of these reasons is why at Tenderly, some 6 years ago, we built one of the first features that we built was a debugger. It sort of helped us solve some of our problems while we were building on hackathons, etc. So what are some of the frustrations that happened during the debugging? And this is not just for our debugger, this is basically for any debugger, for any EVM debugger. So usually we get the incorrect source code for the given instruction. This can happen in a case where Solidity source maps don't point to the right line of code. Other things are misidentified function calls. So what Solidity optimizer can do sometimes is when they see, when the optimizer sees two blocks of code that are usually identical or almost identical, it's going to use only one of those. So it's hard to navigate, and it's hard for us to showcase which exactly function is called in that case. Error in decoding function parameters. This is something that quite often occurs. It's usually hard for debuggers to pinpoint where the value of some parameter is. Is it on stack? Is it in memory? Is it in storage, etc.? And this is even harder for some of the more complex structures in Solidity or Viper. Bad or, if any, local variable detection. Especially when the optimizer is enabled, we are usually unaware of where the variable is on stack. Is it a pointer? Is it a value, etc.? And there are numerous other minor inconsistencies and errors. These are all some of the problems that we hope that Ethdebug format is going to solve. But so first of all, what's a debugging format? So it helps us make sense of the bytecode that is being executed on the EVM. So we all write code in the Solidity or Viper. Maybe like less than 1% of the people write direct bytecode. But like for the people that write Solidity or Viper, we need some way to map instructions to high language features, such as, for example, function, variables, etc. The thing is that when we talked to the folks at Solidity, they told us that compiler has most of this necessary information during the compile time, but they don't output it. And so there is a need for this debug format due to the data complexity that exists and various compilers' differences. And for all of these reasons, we need the EVM-specific debugging standard. So it won't just be for the Solidity, it should, all the EVM languages should apply it. And it should account for the unique aspects of the EVM, such as 256-bit memory locations, gas, data storage methods, etc. So what's the current state of the debugging today? In short, there is no reliable way to build a debugger. Simply put, the compiler doesn't output the sufficient amount of information for us to build a reliable debugger, or even in some cases, existing data can often be unreliable or mislead us to thinking it's something it's not. Therefore, we deploy some of the heuristics and guesswork, but of course, there are certain edge cases where those heuristics or guesswork don't work, simply don't work. This is usually the case when the optimizer is enabled or where UL optimizer is enabled. In those cases, we simply mislead the developers, and we hope that debug format is going to solve most of these problems. And the last thing is that mapping storage slots to variables is relatively complex. We can do it. It requires much more compute today, but ideally, Solidity compiler can point us in the right direction of the storage slots. So some of the key problems that this format is aiming to solve. So there are a lot of things, but hopefully with 4 of these, it can solve most of the problems for people building a debugger. So first is type definition. So ideally, for every structure, ideally for every type, we should have a structure of it. We should have a name, field, declarations. And the idea is to have an information on how to detect it, like where it is. Is it on stack? Is it in memory? Is it in storage? For some more complex structures, ideally, we would have pointers. So for example, if there is a memory of array of structures, we would have an information of where it is and what's the location, and ideally, something that can tell us how to decode it. As you can see, like pointers can be anywhere on stack, memory, storage. Now after that, transient storage, call data, return data code. On top of that, we would need source locations, so some way of mapping how each instruction on the EVM corresponds to the high-level source code. Currently, we use source map for these, but it can be quite unreliable, especially in the cases where UL optimizer is enabled. And the other thing is what I talked at the beginning. So in certain cases, the optimizer is going to deduplicate some of the code segments. Ideally, we can have information pointing us to the multiple locations, and ideally, of course, tell us how to determine which one it is. And the last thing is variable decoding. One of the most painful things, I would say, today is for someone who is building a debugger is so some way to represent variables visible in the scope. Right now, what we do is we basically deploy a bunch of heuristics in order to determine what variables are on stack. It's quite hard for us to know if the variable is optimized out, meaning that it's not even used. So ideally, debug format should tell us that, or what could be even better is a way to reconstruct some of those optimized variables. Now, this format is in, we have first draft of the specification. Afterwards, we're going to enroll in the implementation phase. After we have the implementation phase, we're going to be talking like what we could have with better data. So after we do that, we can have 100% accurate code locations. We can decode function call stack. We can be certain about all the parameters that are inside of the functions, like what's the input, what's the output. We can have all the variables in the scope. We can know which variables are optimized out, meaning they are not used. We can fully decode memory. We can have 100% accurate storage slot decoding. We could have evaluate expression without the need of the compiler or set them to watch variables. And of course, line-by-line debugging. And so much more. I mentioned at the beginning that we are going to have a quick demo. So this is a very, very early proof of concept that we have built of how the future debugger might look like. On to Marco for the demo.
Yeah. Hi, everyone. I'm going to show a small demo of what we could have in the future. And hopefully it works. Let's see. So here I have a basic ERC20 token implemented. So I'm going to try to run a function in the debugger. And it's going to be a pretty basic function that just mints some tokens in a weird way. So let's go through it. First, we're going to be prompted to enter the parameters of the function, which are some x and y coordinates. And then we're going to start debugging. And the first thing that we can do is actually find the function. It's this one, fish for tokens, and select where do we want to start debugging from. And let's hit a breakpoint there. Then we can hit continue, and hopefully we do stop at the point. Currently, this is pretty hard to do without source locations provided by the new format, since there is a lot of instructions that are jumping around. You can't really create trace points anywhere, so you need some logical ways to stop the code. But in the future, we could possibly map every instruction there is and just have a line-by-line debugger. So currently, what you can see here is just the stack on the top. I have some heuristics parsing the local variables. You can see the inputted x and y values. Yeah, I actually inputted them in decimal, but they're showing up as hex values, whatever. They are the same, trust me. And you can see the local variable today's maximum that has been calculated. We can turn on the instruction history. We can see which instructions were run with some additional information that can be useful to us. We can maybe do some, let's say, watched expressions. If I put in something like x plus 5, we should be able to evaluate that expression. We should be able to do that with local variables. So I'm going to add something like today's maximum plus 1. And hopefully it does evaluate. We can maybe try to evaluate the weekday, which is currently not in scope, since we are not on that line yet. So the evaluator can't do it. But if we go a couple of instructions forward, let's go jump instruction by instruction, or maybe just skip to the next line. And next one, we have the weekday, which is in this case 2. It's calculated in some way. It's like days after start, modded by 7. And the days after start is calculated like in a standard way. You can see there on the line 41 where we actually broke or created a breakpoint. Some other interesting stuff that we can do that we can't really do now is debug YUL. I'm going to turn on YUL debugging, and let's cycle instructions until we hit some YUL code. Here we have, if anybody saw utilities YUL. Did anyone actually see this file before, utilities YUL? No one? It's a file that Solidity generates itself, actually, and it has like some crazy named functions. You can see like function name that is long, like over 128 characters and stuff like that. So yeah, the Solidity generates actually this helper file that we can now debug. We could also debug like any YUL file that you write yourself. Like YUL is a low-level assembly language or an intermediary language. Not many people use it, but maybe we could create a debugger for it if needed. But currently it is pretty hard to do without the debug format, since we are missing a lot of information that would allow us to do stuff like this. Okay, let's turn off YUL debugging. So we saw that we have evaluating expressions, we have breakpoints. Why not combine those two and have conditional breakpoints? I'm gonna hit like a conditional breakpoint on line 49. So I added a conditional that if x, a local variable, is greater than 3, which it is, and if we hit continue, we should hit that breakpoint. And we actually do that. Another thing that we could do reliably is the decoding of, 1 second. We could do the decoding of function stack. Let's try to get that. So yeah, we are currently in the function context of the fish for tokens function. But if we go into the next line, we are going to prepare the parameters, and we're going to jump into the distance function. And you can see the function stack has been, let's say, reliably created. We can do that currently, but it's not completely reliable with the source map, because we often get some inlining or some deduplication that often messes this up, and you can get really, really weird function stacks from like the current source maps. But yeah. So even if we enter the YUL, we can actually see the called YUL function, and that's pretty useful, I would guess. Also, I think that very, in my opinion, useful is like this stack annotating. You can inspect the stack and see which value is what. These gray ones are not really that useful. Anything that's colored in is probably some useful information. I color-coded local variables to be blue, and you can see the third or the second value on the stack is currently calculated as x plus 256. This could be actually pretty useful if you have some values that you don't know the origin of. You can just check, go to the point where you're interested in the value of the storage slot, or sorry, stack slot, and then just check the expression that actually calculated it. And it's actually pretty easy to do once you have reliable source map. Pretty easy to create thing like this. You just remember a tree of expressions, like every arithmetic operation you just track and construct a tree and just show it there in like some representation. But yeah, we can also check out the memory. Let's turn off these and turn on the memory. This program doesn't actually like use some human-readable memory. It usually uses it to generate random numbers. You can see the function down there that uses the ABI encode packed, and the ABI encode packed just dumps everything into memory so it can be hashed, and so you can see those values there. If it were some like values that we could actually read, like humans, it would be useful, but in this example, it's not really that great. The place on, like the memory on the left is actually just bytes, and on the right you have the ASCII representations if they actually mean anything. But yeah, so generally you could debug stuff like this, and I'm just gonna go through until we hit some of the inherited functions from the code in ERC20 token, and you can see here on the stack everything is prepared. You can see how many tokens you fished. It's 2 tokens, that's gonna get minted. You can see who's the caller, who's gonna actually receive the tokens, and you can track the history of the values through the stack and see how they were generated. So yeah, I think this could be improved upon a lot, but for now it's not, I just let it run instruction by instruction with some pause, and we hit the end, and that's it. I'm gonna let Nebojsa continue.
Yeah, thank you, Marko. Now we see how the things could look like after the Ethdebug format is implemented, but what's going to happen beyond? What are some of the benefits of it? Of course, we're going to see improved debugging efficiency, which is going to result in more productivity for the Web3 developer, which is going to result in more applications and more users coming to the Web3 and trying things out. Of course, this format is supposed to be cross-language, so we could see some very interesting cross-language tooling come out, and it's much easier for us as we would have to adopt just to the one debug format and not like for the each language implement debugger. For the security analysis tooling, it's going to, of course, enhance it. There's so much more data that this analysis tool can now work with. It's going to be much easier for the developers in the Web2 ecosystem to join in the Web3 because they're accustomed to having a full debugger and not like some quasi-implementation of it. And with the rise of the AI and LLMs, and with the amount of data that we can now finally extract and have it visible from the on-chain execution, we can train these models and hopefully catch some of the vulnerabilities or potential attacks before they even occur. Of course, all of this wouldn't be possible without people coming and contributing to this debug format. So if you're looking to contribute, or if you have some idea, or if you just want to brainstorm, go to the Ethdebug GitHub/format. We post all of the updates there. Currently, as mentioned, we have draft implementation of the specification, and if you have any feedback on it, please let us know. That's it. Thank you.
Thank you so much. Thank you so much, guys. Are there any questions? We have time for 2 questions.
Can we add any data for it? For example, like you have tested this contract against a local node maybe. Can I use against mainnet data? Like can I check an upgrade against my mainnet data currently? So what are the changes of my storage, the stack storage there?
Mm-hmm. Yeah, sure. That would be one of the improvements that we could add with the debug format, definitely. Basically, anything in the execution layer that is relevant to the high-level programming language, we would be able to decode it.